Assalamu alaikum class. My name is Engineer Hassanza and we are going to start our lecture number 5 from chapter number 2. This is all about turning effect of forces. Turning effect of forces can be movement, center of mass, in terms of center mass, and then stability or equilibrium. So what is movement? Describe the movement of force in terms of its turning effect and relate this to everyday example, and these are the basic contents of our lecture. So what is movement? The turning effect of force is called its moment or torque. So here are some certain examples, like turning effect of tire, turning effect of screwdriver, then turning effect of the electrical motor, the concept of electrical motor and a load trolley. Then what is moment factor? The moment of a force is bigger if the force is bigger. The moment of force is bigger if it's farther from the pivot. Pivot is the basically point of rotation at which the our axis of rotation. The point at which rotation takes place is known as axis of rotation or pivot point. The moment of force is greatest if it acts at 90 degree to object it acts on. अभी हम इसकी फर्दर डिटेल भी देखते हैं. So what is moment? Making calculation using moment of a force moment will be equal to force multiply the perpendicular distance from the pivot and the principle of moment. So in simple word, the moment of a force is equal to the force multiplied by the perpendicular distance between the point of action of the force or line of action of the force from the axis of the rotation. This one is the pivot point and here is the line of action of force. So moment will be equal to the force multiplied by the perpendicular distance between pivot point or center axis of rotation and the line of action of the force, which is equal to force cross moment will be equal to the cross product of the force and the distance between the line of action of the force and axis of rotation or pivot point. Here are some tricky examples, simple examples. Calculate the movement of the following: 4 multiplied by 3, and in case of B, 3 multiplied by 2. 3 Newton is the force, 2 meter is the perpendicular distance between axis of rotation point O and the line of action of force. And there are some certain examples you have to solve your own, very easy. Then numerical problem, some objective type theories as well. State the principle of movement for body in equilibrium. Balance beam, as you can say, two forces are causing this seesaw to tip. The girl's weight causes it to tip to the left, while the father provides force to tip it to the right. He can increase the turning effect of this force by increasing the force or by pushing down a greater distance from the pivot. So it means here is the example. We can see how we can increase or decrease the value of the moment by increasing the force or by increasing the distance from the central point or axis of rotation or the pivot point. Principle of movement can be in clockwise type or in anti-clockwise direction. When an object is in equilibrium, it means the sum of clockwise movements on that body is equal to the sum of anti-clockwise movement. So turning effect of force is known as movement. We can calculate the clockwise movement and anti-clockwise movement and clockwise movement. This will be equal to the 5 multiplied 4, 20 Newton meter. Clockwise movement or clockwise torque, or in case of anti-clockwise, 10 multiplied by 2 is also equal to the 20 Newton meter anti-clockwise movement. So it means in case of equilibrium condition, the both clockwise and anti-clockwise movements are equal in magnitude but opposite in direction. Clockwise, anti-clockwise means it's opposite in direction, very clear. These are the examples you have to solve your own. Very interesting and very small examples. Calculate the moment of the 4 Newton force about to. These are the previous. Okay, next one is the condition of the for equilibrium. If an object is in equilibrium, the force on it must be balanced as well as their turning effect. It means the condition of equilibriums are the two conditions. The action and reaction must be equal, and the movement in terms of clockwise and anti-clockwise must be equal and opposite to each other. So here we can say 1400 force Newton force is equal to 500, 200, 400, 300, and for equilibrium condition the forces must be in equilibrium and moment also in equilibrium condition. And here are the examples. Experiment, procedure, these are the some numerical problems. हमने ये वाले न्यूमेरिकल्स भी देखने हैं, जस्ट वेरी स्मॉल, जस्ट लाइक ऑब्जेक्टिव टाइप, और बुक से भी हम करेंगे. So center of mass, the weight on object is due to attraction of the earth on all these particles. The center of mass is the point through which the entire weight of the body object appears to act. मतलब एक ऐसा पॉइंट जिस पे तमाम बॉडी का वेट एक्ट करता है या एक्ट करता हुआ फील होता है, इज नोन एज center of mass. And these are the center of mass of different objects like rectangular, circular, polycircular and triangular form. The above diagram shows the position of the center of gravity for regular shaped objects. And in case of irregular shape, the object will turn until where it reaches where there is no movement. This fact enables us to find the center of gravity of an irregular shaped object. Then there are some experiments. So what is stability or equilibrium? Is the measure of body's ability to maintain its original position, and there are three states: stable equilibrium, unstable equilibrium and neutral equilibrium. Stable equilibrium, it means if we change the position of body, it gains its original position, or if it is able to gain its original position, then this type of equilibrium is known as stable equilibrium. It means if we uplifted a book up to certain height, and if the book again regain its original position, then this type of equilibrium is known as stable equilibrium. And in case of unstable equilibrium, the body is unable to get its original position after it's being displaced. It is this type of equilibrium is known as unstable equilibrium. Then there are reasons of instability. When the rod is slightly disturbed, its center of gravity is lower. The line of action of its weights lines outside the base of the rod. The movement due to weight of the rod propelled it down. तो इस वजह से जो हमारा पेन है या कोई भी रॉड है वो गिर जाएगा, दोबारा अपनी पोजीशन गेन नहीं करेगा. So this type of equilibrium is known as unstable. Neutral equilibrium, it means the body has no effect on its equilibrium condition, either displaced or moved from one position to another position. Its position remains the same. Like in case of circular ball, if the ball is rolled, the center of gravity is neither raised nor lowered. This means that its center of mass, center of gravity is at the same height as the before. So it means if the center of gravity will not be affected by its position or by its movement, then this type of equilibrium is known as neutral equilibrium. Design of stability are there. So this was all about our moment, turning effect of force, then stability. So In our next lecture, we will cover our numerical problem from chapter number 2.